So far, up until now, to run SQL on the server, I've first constructed a static string. This was done by either hard coding all values to be used in the query by string concatenation or using formatted strings. I've then called any one of several execute methods which in general follow the same process when the request is received by the database server. The query is parsed into operable code, which means the SQL syntax is checked and tables and column names are verified. An execution plan is created, which means the database server analyzes the query and works out an optimal way to execute the statement. The result is a compiled statement. Once the statement is compiled, it's stored in a cache on the database server. This means it can be reused without having to be recompiled each time it is executed. Importantly, this compiled statement can also be stored as a special kind of JDBC statement. A prepared statement in JDBC is a precompiled SQL statement. You might remember when we were reviewing regular expressions, we could get a compiled regular expression by using the pattern .compile. In some ways, this is similar to precompiling an SQL statement. In both cases, the string is parsed, which needs to get interpreted as some operation that will occur. The string first needs to get parsed, its syntax tested, and some optimizations may optionally be applied. There is some overhead with this process, so if you're using the statement multiple times, it makes sense to precompile it. A prepared statement is used to execute the same statement multiple times with parameter value placeholders. This can improve performance, as I just stated, since the database server doesn't need to parse and compile the statement each time it is executed. A parameter in an SQL string passed to a prepared statement is defined with a question mark as a placeholder shown in this example. Notice here that I'm not including single quotes around the question mark. This is because when you use a prepared statement, the work of enclosing literals is determined by the type and done for us. When you use the prepared statement, you'll pass the values at that time, specifying their data types as well. This means the values passed as data will never be interpreted as SQL code. Because of this, and very importantly, prepared statements help prevent SQL injection attacks. You can have multiple parameters in the SQL string, and they can be different types. For example, album ID in the songs table is a number. Specifying placeholders is the same, regardless of the type of parameter, as I show here in this example. Let's get back to some code and set up a couple of prepared statements. To demonstrate the prepared statement, I've created a new project called Prepared Statement. I've added the MySQL JDBC driver jar file as a library jar, which you should know how to do by now. I've got the usual main class in this project in the dev LPA package. In this code, I'll again use a data source. In a server environment, you wouldn't be instantiating a new instance of a known driver class like we'll do here, but all other operations would be the same. I'll create a new source with my specific driver here, which gives me a basic data source. You may or may not have to manually include an import statement for this, since IntelliJ may not. You should be able to hover over that class and select import class in most cases if the auto import doesn't work. I use the set methods on the data source to set the server name, so localhost, the port 3306, and the database name, so I'll be using music again for this video. In a previous video, I added a property on the connection string called setContinueBatch on error, which I set to false. Without setting this to false, my batch statements will all get executed instead of stopping at the first error. I can use one of the set methods on my data source to do this, so I'll call setContinueBatch on error. I need to wrap that with a try catch, so I'll use IntelliJ as help to do that. I'll set up my username and password as environment variables, which I've done multiple times. So I'll select Run from the menu, then Edit Configurations. In the dialog, I'll set up the two variables as I did previously. Okay, once we've done that, I'll get a connection next in my code. I'll do this in a try with resources and call getConnection on data source. I'll pass the environment variables for the username and password. I'll add the usual catch clause. Next, I'll set up a simple select statement as a string, which will get data from the music.album view. You've seen this before, but now, instead of using a formatted static string or a concatenated string for the artist name value, I'll insert a question mark there. This is how you parameterize an SQL statement when you plan to use it in a prepared statement. I'll set up my prepared statement, which I'll call PS. I'll call connection.prepareStatement, passing this method the SQL string variable. Next, I can set the value of that parameter by calling setString on the prepared statement. This method takes an index, and again, SQL starts at index 1. I'll pass ELF as the value, the artist, to this statement. I can invoke execute query on a prepared statement as well, which will return a result set. So note, I'm not calling the end quote literal method. When replacing a placeholder in a prepared statement, you specify the type by calling the relevant set method, setString in this case. The server will appropriately end quote literals as needed based on that type. Before I run this, I'll add a printRecords method. I have this method in the Query Music Project's MusicDML class. I'll just paste this into my class, and since I've discussed it previously, I won't rehash it here. Getting back to the main method, I'll add a call to the printRecords after I execute the query. Okay, as you can see, it's not too different from a statement, except when you get a prepared statement, you have to pass an SQL statement to that method. In most cases, this SQL statement is sent to the DBMS when you call prepare statement and it gets compiled at that point. This means the prepared statement object contains a precompiled statement instance that then gets passed to the server when statements are executed. The string that gets passed to the prepare statement method can optionally contain parameters. Parameters are specified using question marks in the query statement, as I showed you on the slides, so these are placeholders for data. I can set the parameter values by calling a set method. These placeholders are another important feature of the prepared statement. They ensure that user input is always treated as data values and never as executable SQL code. This makes it difficult for attackers to inject malicious SQL statements. In this case, you use setString to set the data value. If the data type is something else, there's a whole series of set methods to choose from, like setArray, setBlob, and the usual ones, setLong, setDouble, and so forth. I'll run this code. And here I get the data for the artist ELF's 2 albums. Another important aspect of the prepared statement is its ability to be reused. I'll next use prepared statements to again insert data into the music database. This time I'll insert the data from a CSV file. You can find this file, named newalbums.csv, in the resources section of this video. I've included the file at the root of my project folder. I'll open this so you can see what it contains. In this case, I've got 2 of Bob Dylan's albums set up as a series of records. This looks a lot like the album view. Each record has the artist name, the album name, the track number, and the song title. I'll start with the parameterized strings as static strings. The first will be the artist insert statement. This is a simple insert statement that inserts one parameterized value, the artist name. Next is the album insert statement. The album insert statement has 2 columns which need to be added, the artist ID and the album name, so I'll set up 2 placeholders. Lastly, there's the song insert statement. Here, we've got 3 columns and 3 placeholders for album ID, track number, and song title. Next, I'll create a method called addArtist. This will take a prepared statement, a connection, and an artist name. It throws an SQL exception. I'll initialize the artist ID to -1. I'll set the first parameter to the artist name. I'll then call execute update to get the insert count. If the count is greater than 0, I'll get the generated key, which is the artist ID. I get any generated keys by calling getGenerated keys on the prepared statement. that returns a result set containing the keys. I'll get the first key since I'll only have one record. Then I'll set ID to the first field in the result set. I'll print that out. Then I'll return the artist ID from this method because I'll need it when I insert the other records. I'll copy that code and make a copy directly below. I'll change the name to add album and insert an artist ID as the third argument. I need to change artist name to album name for the fourth argument. In the ps.setString statement, I have to both change the parameter index from 1 to 2 and change artist name to album name. Next, I'll change album ID to artist ID in 4 instances. So first, when I'm declaring the first variable. Then in the ifGenerated_keys.next block, where I assign the generated key. Then I wanted to print album ID in the statement after that. Lastly, I'll return album ID, not artist ID, from this method. Finally, I need to include the artist ID as the first parameter that gets set on the prepared statement. The first parameter in the SQL is for artist ID. This time, I'll use setInt to do this, passing it artist ID. For the next method, addSong, I'll just type this one in. This method starts the same way, so private, static and int. I'll call it addSong, and the parameters are prepared statement, connection, album ID, track number, and song title. This also throws an SQL exception. I'll set the initial value of the song ID to -1. The first parameter is the album ID, an int. The second parameter is another int, the track number. And then song title, a string, as the third one. I'll call execute update on the prepared statement, and that returns the number of rows inserted. If something was inserted, then I'll retrieve the generated key, the song ID. First, I'll call next on that result set. Then, the first column will contain the song ID. I'll print that out. Now I've got add methods for all 3 tables related to an artist. I need to create a method that loops through the records in the CSV file and then calls each of these methods appropriately. Because this video is getting a bit long, I'll end this video here and finish coding this last method and running the code in the next video. So I'll see you in that next video.